Hello, Math 150 Applied Calculus students. I'm getting ready to do section 5.4, the definite integral, and we've already looked at the indefinite integral. If you recall, it looked a lot like this symbolism here, the integral or the antiderivative of f of x dx. Now the definite integral has these limits of integration, and we're going to see what those represent today. There's a little bit of a development here as to where that symbol comes from. It comes from the shape here, comes from a tall S, which stands for sum, summation, adding things together. And that's what we're going to be doing today. We're looking at what's called the area problem. And it says find the area between the curve f of x equals 0.25x squared plus 1 and the x-axis on the interval from 1 to 5. Sketch the area. So I will be sketching this area. I kind of got this started. There we go. What I do is I put it in the calculator, and then I looked at my table, and I'm going to plot that over here. So we've got it's going from 1 to 5. So 1 is 1.25. Here we go. 2 is 2. 3 is 3.25. 4 is 5. And 5 is 7.25. So I just took those right out of the calculator. You know it's a parabola. We're looking at 0.25 x squared plus 1. It's a parabola that opens up, and we're only looking at the part from 1 to 5. There we go. And the area we're looking at is the area from this curve to the x-axis. So whenever it says the area under the curve, it means the area that is between the curve and the x-axis. This is the area we're looking for right here. And to find an area of a curved shape took a while to develop historically. I mean, we had areas of things that didn't have curves, like rectangles and squares and objects like that, you know, and we're going to actually use that area of a rectangle today, length times width. We know area of triangles, things that have flat sides, but this is a curved side. And what we're going to do, we're going to approximate the area, I'm saying right here, by using left and right rectangles. All right, so we're going to use rectangles to approximate this area. So first thing I'm going to do is take a look at this again. What was it at 1 was up here at 1.25, and 5 was up here at 7.25. And here's the curve. 2 was 2, 4 is 5. And I want to approximate this by using rectangles. And what we're going to do is divide from 1 to 5 into 4 rectangles. 1, 2, 3, 4. So what we do is we take, and I'm putting this right here, bear with me, the interval from 1 to 5, and I'm using 4 left rectangles. We're taking this distance divided by 4, and you do that by taking b minus a over n, and this is your a and this is your b. So I'm taking that interval, I'm taking b minus a over n, so that gives me 5 minus 1 over 4. That comes from here, and I'm using 4 for 4 rectangles, and I get 4 over 4 is 1, and that's called delta x. That's a change in x, and this is going to be the rectangle width, and the rectangle height, we're going to use the left end point. All right, so from 1 to 2, let me come over here. From 1 to 2, I'm going to come up to the height of the left part from 1 to 2, come over to here, and I'm building my first rectangle right there. Okay, so that is a rectangle. We're going to use left rectangles to estimate this area. And my next one, so if I'm dividing this by 4, so I'm taking this from 1 to 5 and dividing it into 4, and that gives me a 1. So each one's going to have a width of 1, and the height comes from the left endpoint. Well, the left endpoint is where the 2 is, and I come up to here, and I draw my second rectangle. Not very pretty. So this is what I've done. I've said, okay, from 1 to 2, and then 2 to 3, 3 to 4, 4 to 5. I've got 4 subintervals, and they all have width 1. And I take the left end point, which is 1 on this one. I take 2 as the left-hand end point here, 3 is the left-hand end point, and 4 is the left-hand end point of what are called subintervals of this interval. And the left end point being 1, if I put f of 1 in here, it's 1.25. So I know that this went up as high as 1.25. All right, and then the left-hand end point, that's as high as 2. I kind of got out of whack a little bit. Now this next one, I'm going to use the left-hand end point to come up to the curve, go over here, and come down, and that is going to give me a rectangle. And then this last one, I'm going to come up to the curve on the left-hand side and come over to here, and that'll be my last rectangle. So these are my 4 rectangles, and I'm going to find the area of this one, this one, this one, and this one. Now I'm doing this because this is curved. I'm trying to find this area, but I can't because I don't know how to deal with curves, but I do know how to deal with rectangles. So right here I have 4 rectangles. They're left because we're using the left-hand endpoint for the height. And remember, f of 1 is 1.25, which I got from here, which I got from plugging 1 in here. So the height of this rectangle is 1.25. And the width is 1. So this is a 1. And the height of this one is as high as the left-hand endpoint, f of 2, which is 2. So the height of this one, I'm going to write it f of 2. That's the height of this one. The height of this one is f of 3. The height of this one is f of 4. So I'm getting a look at my rectangles. They have a width of 1. Each one has a width of 1. And the height, this one's 1.25. The height of this one is f of 2, which was 2. And the height of this one was f of 3, because we're plugging that left-hand endpoint right there. That's f of 3, which is equal to 3.25. And then this last one, f of 4, is 5. So if I take length times width, here we go. Area 1, so I'm calling this area 1 right here. This one's area 1, this is area 2, area 3, area 4. So those are my 4 rectangles. My area 1, I'm just taking width times height. The width is 1. The height was 1.25, so that gives me 1.25. Area 2, the width on each one of these is 1. The height was 2, so I get an area of 2. This one's 1 times 3.25. I get 3.25, and the area of the fourth one is 5. So I know the areas of these 4 rectangles. Now I take what we call L4, which is using the left-hand endpoint, add up those areas, and I'm getting 11.5. So the area that's shaded is 11.5. Now the question is this an underestimate or an overestimate? Is this less than the true area, or is it more? And you'll see that there are these little corners that are open. So this is an underestimate. I'm going to write underestimate here. And the 11.5, so the value we got is less than the true area. We're going to come back and do a write.